For our next example, once again, we're going to have to practice a little bit of nomenclature, and we are going to have to write a balanced chemical equation to get started. Iron 3 oxide can be reduced to iron metal by heating it in hydrogen gas. Water is a byproduct of the reaction. Right. We're going to have to figure out how we write the chemical formula for iron 3 oxide. That Roman numeral 3 is telling us that iron has a charge of 3 plus, oxide has a charge of 2 minus. So if we're going to do our crisscross here to get charges to cancel out, we're going to end up with Fe2O3. I skipped a step. The first thing I should have done was to identify that this is an ionic compound. It's a metal plus a nonmetal. Iron is a metal, oxygen's a nonmetal, so metal plus nonmetal makes it ionic. And therefore, we have to consider charges. Since the charges don't cancel out, we crisscross, and we end up with Fe2O3. So we have Fe2O3, and it says it can be reduced to iron metal. That means that our product is going to be just Fe. We're making iron, and this happens by heating it in hydrogen gas. So that means that Fe2O3 is reacting with hydrogen. It also says that water is a byproduct of the reaction. A byproduct is a product. When we throw that prefix by on it, it just means that it's not one we're really interested in. We're trying to make iron metal, and water just happens to be made along with it. To balance this equation, it looks like oxygen is, well, maybe not. Yeah, I'm just going to go left to right balancing this. So let's start with the iron. We've got 2 irons on the left and only 1 on the right, so I'm going to put a coefficient of 2 in front there. I've got 3 oxygens on the left and just 1 on the right, so I'm going to put a coefficient of 3 in front of water. That gives me 3 oxygens. On the left, I have 2 hydrogens. On the right, I have 6 hydrogens, so I'm going to put a coefficient of 3 in front of H2, and that looks like everything balances okay. We were given 100 grams of iron, so that's what we're going to start with. Always number, unit, and chemical. So 100 grams of iron. And then our next step, since we have grams instead of moles, we've got to convert this into moles. So I'm going to put grams of Fe down on the bottom, and I'm going to put moles of Fe on the top. As long as the chemical stays the same between the top and the bottom, this is a mole triangle conversion. On the mole triangle, grams is associated with molar mass. So if we go to the periodic table, we're going to have 55.85. Moles is associated with the number 1. So that converts our 100 grams of iron into moles of iron. So if we stopped and did the calculation right here, we would figure out how many moles of iron are in 100 grams. But that's not what we were asked for. We were asked to figure out how much Fe2O3. So I need to convert to a different chemical. So my next step is going to use the coefficients from the balanced equation to convert chemicals. So I'm going to put moles of Fe down on the bottom and moles of Fe2O3 on the top. And the coefficients from the balanced equation are going to give us this ratio. 2 moles of Fe for every 1 mole of Fe2O3. And then our last step here is going to go from moles of Fe2O3 to what we were asked for. We were asked to find formula units. So up top, I'm going to put formula units of Fe2O3. I left myself a little bit of space there because that's a big number, a long number to write. Because Fe2O3 is the same in the top and the bottom, this is just a unit conversion. We're converting between moles and formula units. That's a mole triangle problem. So on the mole triangle, moles is 1, and formula units is Avogadro's number, 6.02 times 10 to the 23rd. Let's make sure our units all work out. Grams of iron cancel with grams of iron. Moles of iron cancel with moles of iron. Moles of Fe2O3 cancel with moles of Fe2O3. And when I run that through my calculator, I'm going to get 5.39 times 10 to the 23rd formula units of Fe2O3. For the alternate way of working this problem, we're still going to need the balanced equation. The balanced equation was 1 Fe2O3 reacts with 3 hydrogens to make 3 waters plus 2 irons. And let's see, we're going to start the exact same way. We were given 100 grams of iron, so I'll start off with 100 grams of iron. Oh, I think I got sloppy on sig figs here too. In my in-class notes, I added a decimal point so that we ended up with 3 sig figs. I forgot to put that on the previous slide. So 100 grams of iron. And then for our conversion factor, we need to match down in the bottom the unit and the chemical we were given, and we want to write up top the unit and the chemical that we are trying to find. For the unit of grams, we go to the mole triangle and it says molar mass. So from the periodic table for iron, that's 55.85. The second number we're going to tuck in down here is the coefficient from the balanced equation, so that's a 2. Up top, with formula units, we're going to use Avogadro's number because a formula unit is a type of representative particle. And we're going to add the coefficient for Fe2O3, which is a 1. And run those numbers through the calculator. And we're going to end up with 5.39 times 10 to the 23rd formula units Fe2O3. Both of these approaches are strong. Just pick the one that works best for you.